Welcome to Topo Kit 101. This is Topo Kit Basics, the first part in our series. And here I just want to explain some really basic things about Topo Kit and just give you a taste of how Topo Kit is going to help your workflow. All right, so let's start with the first overview here. We're going to look at how we create a mesh from some contours and maybe even some spots. We're going to look at how we can create walls to manipulate topography. And then finally, we're going to look at how to create areas that can be then projected to the surface of a topo mesh and can really help us to define different materials or other kinds of area type geometries. So now let's look at, first of all, contours and spots. This is called a geopipeline in Grasshopper. And what's happening here is this, here I'm going to hit Control Q. And this is going to show which geometry. So Control Q is the same as if I were to middle click and change the preview to on or off here. This is off with the blindfold. Control Q, I can turn that off. But if I turn it on, I see that all of these curves are being referenced from my Rhino file. And this is really nice. I really like working this way because what you can do is draw things in Rhino and it will get pulled in directly into Grasshopper. We can also do the same for spots. So this here is a spot. These are different kinds of spots. We'll talk about those in a second. But this spot, for example, if I just move this up, it's actually changing the topography. I'll just undo that and hit Control Q to hide this as well. So Topo Kit, these are our components here for Topo Kit, which is part of Land Kit. We're going to pull in our contours and feed those into contour curves into this component, which is a geoset component. So this allows you to add to a geoset or create a new one if you're not inputting one. So here we're not actually inputting a geoset, and we're also creating, bringing in spots. And we don't even need this curve thing to be on. We can turn that off. Just double click that. These little icons at the bottom allow you to decide which kind of geometry you're pulling from your layer. So here we're pulling curves, and here we're pulling spots. Now, these two different types of geometry are being categorized in a very particular way here when we create a geoset. And this geoset can then be brought into the Create Topo component. It's just one object that gets brought in. It's not geometry, but it has sort of references to geometry within it. We can also use features, which we'll talk about in a minute, to create our topo. But once we have our topo, we can't actually, interestingly, see it. We're thinking about different ways of potentially previewing. But this is actually great because we can do all this different stuff computationally with the topography and then draw it. So we'll get into that in later modules of this course. But right now, we're looking at how to essentially just very quickly bring in contours and spots in order to make a topo instance that we can draw. All right. Now, this component, the topo, the draw topo component, allows you to set a minimum number of divisions within your curves or a maximum number of divisions and an angle tolerance. So let's preview these points used. Control Q. And these are the points that are used to define our mesh. If I zoom in, see this curve, this reveals the most about this whole process. While on these other curves, you have a minimum of 3 feet. See here, you have 3 feet. There's a maximum length of 3 feet. Here, we have a minimum division of 1/4 foot. So if this was a very, very sharp curve, we would have a minimum length between each point of 1/4 foot. And I can make this even tighter if I just say 0.1. And it adds in a bit of geometry. Now this has to do with a Rhino algorithm, and there's a little bit more happening here, and we can start to see, if you notice, this actually had a slightly tighter density as well. So there are some small inconsistencies with this based on some things that are happening with Rhino, but overall, you can change the settings of how topography is drawn based on these curves. Now, the output, very simply, is a topo mesh. So this topo mesh that we have here, we can preview that in another way, which is to sort of cut contours through that. This is the contour component that's native to Grasshopper. This is not part of LandKit. And you can see what it looks like. I'm going to minimize this a little bit. You can see what this looks like whenever we cut through this geometry. And I'm going to turn off these points. These contours are cutting every foot. Now, the contours that we've put in aren't necessarily set at an elevation. If I were to draw a point, you can see down here at the bottom, if you look here, you can see that it's 18.51 feet. So these contours aren't actually drawn at a particular elevation. And the interesting thing here is that these geometries can be drawn at wherever they need to be. Like if you have a terrace that's at a certain elevation, you can create a contour that's not necessarily at a particular foot height. And from here, these contours, which we can eventually export and even bring into CAD for further refinement, these contours will allow us to see an exact elevation that will be reflected within our CAD drawing. All right, so let me hide this and hide this, and we're going to look at the next step, which is to create basic topo with some features. So if I have a similar thing here where I'm pulling contours and spots to create a geo set. That geo set is being used to create topography, and then that topography is being drawn. Now, and let's look at the preview. So these are our contours. These are set at a much higher density. We can actually change this to 1 foot or 0.1 foot, right? So now, one thing missing here, I'm drawing walls. I create walls using wall curves, which are down here. There's only 2 wall curves, a front curve and a back curve, but there's nothing to delineate which is the front or which is the back, other than spots, which are drawn in 3D space. Now, if I look from the top, I see 2 spots which are drawn at the back, and a few spots which are drawn in the front. These spots in plan are effectively right on top of the curve, but in 3D, they're elevated to where they're supposed to be, at elevation. So if I look here, I have spots, these green dots, and I have curves here. Now, those are being used to create walls. And And there are some tolerances that we have to set. The first tolerance is how close do curves need to be together to get matched. Because you see, you don't just have to draw only two curves at a time. We could, hypothetically, if we were drawing, if we had multiple curves and spots, we could actually draw another wall over here. And this same component, this geo pipeline is pulling in geometries from that layer. So now we have 4 curves and twice as many spots, not 6, we have 12. And those are all getting sorted out and creating 2 walls. So just by simply copying the geometries from one wall sort of set of geometries, we kind of can build a whole other wall. These tolerances help to figure out how that is sorted out. So the curve tolerance of 2 feet decides that these curves are 2 feet within proximity of one another at their midpoint, and therefore will be grouped. These curves, I'm really clicking on all the wrong stuff here. These curves will be grouped together as well. And then the spot tolerance determines in plan only how close spots need to be associated with a wall or wall curves. So here, these spots are drawn exactly at this point, but if we were to draw them slightly off, as we do here, it's going to be forgiving up to 0.2 feet or about 2 inches or so. Because a wall doesn't need to be, a wall is generally not going to be any thinner than half a foot or something like that. And we can sort of use these tolerances to kind of hit a general range that's reasonable with what we're drawing. Finally, once we have walls, just like with the topography, we can preview those now. So we can see the kind of outlining curves that are going to be used to draw a wall. That's kind of neat. And then I can hide that. We can then draw walls. And if I preview this, I'm pulling out the geometry of the wall, and then I'm going to preview that in a preview component. And here I can see actual wall massing, which is all based on the points. There's a little bit of a part of the wall which gets pushed under the grade, just in order to make sure that there's no seams that you can see or whatever, things like that. And eventually I think we're going to make some more options for how you can adjust that. Finally, that wall, and if we look at our contours and our topography now has nothing to do with these walls. But if we plug these walls, this is the wall object, or these 2 wall instances, we can plug these into the features of Create Topography, and that will now edit our topography. I'm actually going to take these points and I'm going to rotate them 180 degrees. Watch what happens. See how it automatically changed the topography so that rather than this being the high side of the wall, this becomes the low side of the wall? Well, both of these walls are not only, being drawn in 3D where we could actually export or bake that geometry. Sorry, I'm getting a little lost here. Where we can bake that geometry. If I say insert, if I click the insert key, it inserts a surface here, and this is a wall geometry. But it's also utilizing the particular curves that are going to eventually affect the grading, like the breaklines, which is what we call them. See here, it's actually, it doesn't actually say breaklines here, but whenever we plug this into the Create Topo, it's the same as using breaklines in the geo set, which we're going to talk about in later modules. But basically, the thing that you have to understand is that you're not only using contours and spots to create your topo mesh and eventually different topographic areas that are three-dimensionally drawn. You're not just using contours and spots, you're also using walls and curbs, which we'll show you eventually, and paths and some other ways of defining the topography. So let me hide these, and I will hide this as well. I'll delete that, and I'm going to delete this wall as well. Now, I've been mentioning a few times this idea of areas. So if we just simply preview this, Control Q, what is happening here is that these surfaces, which are flat and defined by trimmed surfaces, are being projected to a topographic mesh. So just like above, we're creating, oh, actually this topographic mesh is being created from here. It's being pulled from this second example that we just looked at. And these areas are being referenced directly. We could use a geo pipeline to reference a particular layer, but right now we're just using this. We right click and we say set multiple breps. A brep is another way of talking about a solid surface or just a single surface. And by solid surface, I mean poly surface or a solid that is defined by a closed set of surfaces. Now, this particular brep, or this really is wants to be a surface, but it can be a joined surface if it needs to be. We're going to create areas, and there are different tolerances here, which we'll talk about later. We are setting an edge tolerance of 2 feet, which means that there's going to be no greater edge length than 2 feet. So if we were to, let's look at the edges of this mesh. So I'll type edges mesh. And then you can see here that these edges are approximately 2 feet. Their distance approximately 2 feet from one another, from vertex to vertex. Now, this mesh is projected, and if we let's change this to 1 foot. See how quickly that is? Now, fortunately, this is a very small topographic mesh, and things are very responsive. But as you start to get into more complex meshes, there are some other techniques that we can use to avoid things going more slowly than we want them to. Another thing that we can do with our areas is draw them as surfaces. In this earlier example, we drew meshes. This component can spit out projected meshes, also flat meshes. It'll give you other information that you put in earlier on, sort of keep track of it all. And this component is very similar, but the biggest difference is that it will give you surfaces instead of flat meshes. So let's, just in the example here, we have a toggle. So if I make draw as surface true, just double click that to change it from false to true. And it's got to think for a second because surfaces take a little bit longer. If I zoom in here and look at the contours that are being cut, see it's going through the same pipeline that the mesh was going through. These contours are very smooth, and they're looking really nice. Now, if I look here, there's 2 surface types. If I zoom in, there's a grid or a patch. And right now we're using a patch. And for anybody who's done patches, they might be looking at this and saying, how is that a patch? Patches are often very interpretive of contours in ways that we don't like. They'll overshoot, or they'll they just won't work with the contour. They don't hit the contour. So one thing we can do, one thing we've done is take the area, the mesh area, is actually being drawn here, and then we're patching through that. So it's creating a very good mesh. But as you can see, it takes 4 seconds. This is sort of the performance option for Grasshopper I've got turned on here. And the profiler. This is taking a bit longer, even just to draw these two surfaces on this moderately sized site, really rather small site. So this is something to take note of. Surfaces are going to take much longer. There is another type, which is a grid, and that is actually a little bit more direct. And you'll notice that it draws it in 3 seconds rather than 4. And if we plug this in again here, we may notice that it potentially draws it even faster. Or who knows, or slower. Looks like it was exactly the same. But the there's, you know, some potential or possible issues with the grid. Here we can see that the grid, because this is sort of cutting at an angle, the grid is interpreting that and is sort of giving us a little bit of a waviness to it. But it's still very close, and for a rendering, this could be not too bad. Now, if I select this and I bake this by right-clicking and baking, or I can middle-click and bake, I can see that I have a surface that's fairly reasonable to adjust and manipulate. That, you know, isn't, you know, there's still a fair number of control points if we were to turn those on, but it's very closely following this zone that I've defined here, this area, and the topography. So that is areas as meshes, as surfaces. We're cutting contours to visualize the sort of accuracy of that surface. And then this is a preview module. If I just hit Control Q to sort of show that, I can turn off these or delete these baked versions. And I have some nice preview of the mesh as well, or the surface rather. I know some people like to use surfaces over meshes when they're dealing with stuff like this, because they can then, you know, after the fact, they can trim and, you know, untrim and kind of have a little bit more flexibility. The thing to note, well, one thing you'll notice, this grid can run into some strange issues if you're following the grid. The patch is not bad. It takes a little bit longer, and you know, it gives you a few options to test things out. But otherwise, that is Topo Areas, and that concludes our Topo Kit basics. We're going to dig into all these things again a little bit more thoroughly in the other modules, but hopefully this gives you a pretty good sense of stuff you can do really easily right away using your contour geometries or spots. You can create your own walls, etc. All right, thanks.